Welcome to Catalyst MedHub, where we ignite understanding and make learning easier. Today we'll be looking at one of the important topics under Maths 101. Now, look at the nature of this number. If you have 2, 4, 6, 8, and 10, can you predict the next number? Now, settle down so that we'll learn the mathematical basis behind this nature of this number: time, sequence, and series. So in this video, we'll be looking at the sequence and series. What is sequence? Sequence simply means listing of the number in a particular order. For example, you will list number here: 2, 4, 6, 8, 10, Our next number here, we can predict that our next number should be 12. So the listing of a number in a particular order is simply referred to as sequence. Whereby the series simply means the sum of the times of the sequence. Because in each of the sequence, each number serves as the first time. Here, 2 here is our first time, 4 is the second time, 6 is the third time, 8 is the fourth time, and 10 is the 50th time. So the sum of each time of the sequence is referred to as series. So series can be demonstrated as 2 plus 4 plus 6 plus 8 plus 10. So this is just a brief introduction to sequence and series. So next one is that we'll be looking at the two major important types of sequence and series, which are AP, arithmetic progression, and geometric progression. In arithmetic progression deals with constant difference between the consecutive times, whereby geometric progression deals with the common ratio or the constant common ratio between the consecutive times. Now, moving on to AP, that's arithmetic progression proper. This with constant difference between consecutive times. That is, the differences between each one time are always constant. For example, if you have 2, 4, 6, 8, and 10, here this is a typical example of arithmetic progression. Because if you look at 4 minus 2, it will give us 2. 6 minus 4, it will give us 2. 8 minus 6, it will give us 2. 10 minus 8, it will give us 2. So the difference between the two consecutive times is always constant. So in this case, we are having 2, 2, 2. So this is a typical example of arithmetic progression. And there are things you should take note in arithmetic progression, like number of times of arithmetic progression and the sum of arithmetic progression. So now moving on to the number of times of arithmetic progression, it can be calculated using Tn equals to a plus n minus 1 multiplied by d, where a here is first time, n here is number of time, d is common difference. Another thing you should know in arithmetic progression is sum of AP. Sum of an AP can be calculated majorly by two formulas. The first formula is sum of an AP equals to n all over 2, a plus n, and sum of an AP equals to n all over 2, 2a plus n minus 1 d. These are the two major formula that we can use to calculate sum of an AP, where a is first time, n is last time, and this last time will also be calculated using n equals to a plus n minus 1 d. Then our n is number of time and d is common difference. So these are the important formula that we should take note if you are dealing with arithmetic progression or AP. Let's solve question under AP. So the first question says that what is the fifth time of a sequence minus 3, 2, and 7? So question 1, solution. Question 1, we say that the number of times in an AP can be calculated using Tn equals to A plus N minus 1D, where A is our first time, that is our T1 is A, then our T2, our second time will now be A plus D, our third time will be A plus 2D, because our N will be, for the second time, our N will be 3 minus 1, 2, then 2 times 0 is 2D, our fourth time will be A plus 3D, our fifth time will be A plus 4D. This is the pattern of it. So you understand what is the 50th time of the sequence? Well, the sequence is minus 3, 2, 7. First thing we should look at is that here our first time is minus 3. Then we have to look for the common difference. Common difference can be calculated or can be gotten by subtracting first time from second time from third time. So from here, we'll be having second time minus first time, that is 2 minus 3. So our common difference will be calculated by 2 minus 3 to give us 2 minus 3 will give minus times minus plus, that is 2 plus 3 to give us 5. Then again 7 minus 2. 7 minus 2 is 5. So here, since we are having 5, our common difference is 5. For you to get your common difference, you will do the second time minus first time, third time minus second time, fourth time minus third time. So from here, our common difference is 5. Now we are looking for the 50th time, that is T15. That is what we are looking for. Using the formula, T15 will now be equal to our A is minus 3 plus bracket of the number of times we are looking for is our N, that is 15 minus 1 multiplied by our difference, which is 5. So T15 will now be equal to minus 3 plus 15 minus 1 will give us 14, 5. So T15 will now be equal to minus 3 plus 14 times 5, 17. So our T15 will now be equal to minus 3 plus 17 will give us 67. So the 50th time of this sequence, minus 3, 2 and 7 is 67. The next question states that the 50th time of an AP is 72. And the first time is 2. Find the number of the times in the AP whose last time is 302. Now let's bring out the data we are given. They say the 58th time, that is T15, is equals to 72. Okay? And the first time, our A, which is the first time, is 2. Then I said I should find the number of times we are looking for N now, in which the last time is 302. Our last time is 302. So here now we are looking for the N. Now what formula are we using? From here, we say that the formula for the last time is N equals to A plus N minus 1D. Okay, so from here, our N is 302 equals to our A, which is 2 plus the N, which we are looking for, minus 1D. So we have to go and look for the common difference, because we are not getting common difference from the question. How do we get the common difference? Remember, we are given the 50th time. You can get the common difference from 50th time using T15 equals to A plus 14D, because it's N minus 1D and our T is 50. 50 minus 1 is 14 multiplied by D. So we are having T15 equals to A plus 14D, and our T15 from the question is 72. So 72 equals to our A is 2 plus 14D. From here, we collect the like times. We are having 72 minus 2 equals to 14D. 72 minus 2 will give us 70 equals to 14D. From here, we make our D subject of the formula to give us D equals to 70 divided by 14 is 5. So our common difference is 5. Then come here, you'll be having 302 equals to 2 plus n minus 1, 5, because our D is 5. Opening this bracket, you'll be having 302 equals to 2 plus 5n minus 5, because n times 5 will give us 5n, minus 1 times 5 will give us minus 5. From here, we collect the line terms as 302 minus 2 plus 5 equals to 5n. 302 minus 2 plus 5 will give us 305 equals to 5n. From here, it is n we are looking for, because from the question, find the number of times. So we divide both sides by 5 to get n. Our n will now be equal to 305 divided by 5 to give us 61. So the number of times that we are looking for from that question is 61. This is how you can get the number of times. The next question is in an AP. The first time they give us first time to be 5. And they give us common difference of 4. D equals to 4. Then after that, if the last time is 205, okay, we are given last time again as 205. Then after to find the total number of times we are looking for n now. It's straightforward and very simple. Use the formula of the last time, which is n equals to a plus n minus 1d. All the data needed here it has been provided from the question. So our last time we say is 205 equals to our first time, which is 5 plus n minus 1. The common difference is 4. Open this bracket, you'll be having 205 equals to 5 plus 4n minus 4. Collecting like that, 205 minus 5 plus 4 equals to 4n. 205 minus 5 plus 4 will give us 204 equals to 4n. From here, we'll make n sort of the formula by dividing both sides by 4. So our n will now be equal to 204 divided by 4. Our number of times will be 51. So that is the answer to question 3. The next question is, how many multiples of 7 lies between 21 and 700? So from here, our first time is 21. That's how many multiples of 7 lies between 21 and 700. From here, our first time is 21. Then 21 plus 7 will give us 20, because we said 7 multiples of 7 lies between 21 and 700. The next time will be 28 plus 7, 35, all to 700. So from here now, our aim is our first time is 21. Our last time is 700, then our common difference will now be what? 28 minus 21, it will be 7. 35 minus 28, it will be 7. So our common difference is 7. Now looking for the number of the time, because that is what the question is asking us there. Now we'll be having n equals to a plus n minus 1d. Then our n, that's the last time, 700 equals to our a, which is 21 plus n minus 1d. 700 equals to 21 plus, okay, 21 plus n minus 1, and our common difference is 7. 700 equals to 21 plus 7n minus 7. So from here, we'll be having, we collect the like terms. 700 minus 2 plus 7 equals to 7n. 700 minus 2 plus 7, 686 equals to 7n. It is n we are looking for. Our n will now be 686 divided by 7. So therefore, our n now 686 divided by 7 will give us 98. So this is the answer. The last question here is question 5. In an AP, the first time they give us first time A to to be 7, and the common difference, they give us common difference to be 5. How many times of an AP must be taken to get the last time of 5 or 2? It's the same pattern. Our n is question mark, and then our last time is 5 or 2. Using the formula, n equals to a plus n minus 1d. Our last time is 5 or 2 equals to our a is 7 plus n minus 1. Our common difference given is 5. 502 equals to 7 plus 5n minus 5. Collecting the right time, we are having 502 minus 7 plus 5 equals to 5n. 502 minus 7 plus 5. Okay. So 502 minus 7 plus 5 will give us 500 equals to 5n. Making n sort of the formula, our n will now be 500 divided by 5 to give us 100. So these are the common questions that you can find under AP, that is number of time of AP.